All right, next we're going to look at continuous from the left and continuous from the right. Let me get everything squared away here, and we'll start this part. All right, let's see. Let's see what your book has to say here. Your book says, in general, we will say a function f is continuous from the left at c if the limit as x approaches c from the left of f of x equal to f of c, and is continuous from the right at c if the limit as x approaches c from the right of f of x is equal to f of c. Okay, let's look at this one right here. I'm going to redraw it because I want to be able to write on this, and I cannot write on this screen. So we have a, b, and we have some kind of function like this. So let me get back to my drawing board here. And let's see. So we had something like some axes here. And we had like a right here. We had b right here. We had a function that did something like this. And I believe it was a solid dot right here. An open dot right there. And then a solid dot right here. And they called this the function f. Here's an x-axis. Here's a y-axis, okay? All right, let's see. All right, so continuous from the left. Continuous from left. All right, if we look at this, the limit as x approaches the value of b from the left of f of x. Now, as x approaches b from the left, so we're approaching b here from the left like this. What would you say that is if I call this, say, 4, and this maybe like 3, and that maybe like 2, and so forth on the y-axis? If you had to guess what this limit was, you probably say, okay, as I approach b from the left, my function value there approaches what? 4. Let's say that's 4. All right, what would you say that f of b is equal to? Well, that looks like it's equal to 4 as well. So I'd say this function f is continuous from left at x is equal to b. Not continuous from the right. Continuous from the right. Let's look at a right here. Continuous from the right at a. So the limit as x approaches a from the right-hand side of f of x, what would you guess that is? Look at this. As we approach a from the right-hand side, this function is approaching this output value of 2. So I'd say it looks like it's 2. How about f evaluated at a? What is that equal to? If I evaluate my function at a, my function is defined up here at a, and that might be somewhere around like 6 in this case. So let's say that's 6, it looks like. So since these are not the same, I'm going to say not continuous from right at x is equal to a. Continuous from the left and from the right. All right, so let's go over here and let's look at what we have next. Definition. Let's see what this definition has to say. Oh, I can't scroll. That's why. Let it stay idle too long. All right. A function f is said to be continuous on a closed interval a to b if the following conditions are satisfied. F is continuous on the open interval ab, f is continuous from the right at a, and f is continuous from the left at b. All right, so let's go ahead and work an example with this stuff. Right? Let's see. Erase all this stuff first. See if it lets me do this. Yeah. All right. Now, what if we have an example and it tells us to determine where the graph is continuous? Determine where the graph is continuous. Where the graph is continuous. And they're going to give us this graph as part of the problem, okay? So here we have -3 on my x-axis. Over here I have 5 on my x-axis. And right here, let's go ahead and call that maybe, I don't know, 2 on the x-axis. Let's suppose my graph has an open circle there, goes up right here to 5, has an open circle there, and goes like this to right here at 3, that has a closed or shaded in circle at 3. All right, and let's suppose up here, this is maybe 3, and let's suppose that right here, maybe that's 4, okay? All right, what do they want us to do? Determine where the graph is continuous. So where is it continuous? Let me see, let me erase a little bit here to give me some more room. So let me erase this stuff. And let's take a look at this graph. Well, it looks like it's continuous right in here, right? And it sure is. So we could say it's continuous from -3 to 2. Now we can't say it's continuous at 2 right there because it's not continuous from the left at 2, is it? Because the limit as x approaches 2 from the left is what? I would say that's about 0, right? And that's not equal to the function value at 2 because the function value is undefined at 2 with this open circle. Where else does it look like it's continuous? Just to the right of 2, all the way up to about 5, right? So we could say this, and we could say and, or we could put in union. I'm not sure which one Wiley Plus wants, but you can look at the examples and it'll show you from 2 to 5. So we don't want to include 2 as a continuity or 5 as a continuity. And that's actually what it looks like if you look at this, right? That it's continuous on here, and it looks like it has a break there and a break there. So we're going to say, here's where it is continuous.